Let us now see how we divide polynomials, how we divide two polynomials. There are two methods. The first method is called long division or Euclidean division. This is the most general method. It works for any two polynomials. When I say any two polynomials, I mean any polynomials with any degrees. So this works everywhere in any case. There is, on the other hand, a shorter method, a faster method, which is the so-called synthetic division. However, this method only works for a specific class of polynomials or of cases, as you will see later in this video. Let me first explain what is meant by the division algorithm. I'm pretty sure all of us know what is the division algorithm when I explain it. And I'm going to start with a numerical example. So if I have something like 6 divided by 3, the answer is 2 and the remainder is 0. On the other hand, if I have something like 11 divided by 4, the answer will be 2 and the remainder is 3. We used to do the following in order to check our answers. We used to multiply the 3 by the 2, the divisor, by the answer, and then added to the remainder, and we should obtain 6. So in other words, we must have 6 is equal to 3 times 2 added to 0. If this works, then we are on the right track, and yes, it does. Similarly, in the other example, so I have 11 is equal to 4 times 2 plus 3. Let's see. 4 times 2, which is 8, plus 3, which is 11. This also works. So this is what is meant by the division algorithm. If I am dividing capital D by small d, and the answer, let's call it Q, and the remainder is R. So in general, I must have the following. I must have capital D must be equal to small d times Q plus the remainder, which is R. That is the division algorithm. And capital D is called the dividend. Small d is called the divisor. Q, which is the answer, is called the quotient. And finally, R is the remainder. So that's what is meant by the division algorithm. Now the same thing works with polynomials. And let's start with long division. The best way to explain this algorithm is by showing some examples. I'm going to work out 3 examples. Let's start with this one. So I have 3x squared minus 2x plus 6, which is our dividend, and the divisor here is x minus 1. Let us start. So I place the dividend, I always place the dividend here. So 3x squared minus 2x plus 6 must be placed here. And x minus 1, which is the divisor, I place it here. And by the way, there is a really very important thing before I continue with this example. I must make sure that the terms in the polynomial are arranged in the descending order of exponents. Let me give you an example to make it more clear. Let's say in a different question we have something like negative 2x to the power of 4 minus 5x to the power of 6 plus 7x squared, let's say, minus x plus 8. I cannot place the term, or I cannot place the polynomial like this. I must first of all make sure that it's arranged in the descending order of exponents. So I write it as negative 5x to the power of 6 because 6 is the largest number, largest exponent in this expression. Then we have 2x to the 4 plus 7x squared minus x plus 8. After doing this, I just continue with the algorithm. So please make sure to check that the polynomial is arranged in the descending order of exponents. All right, after this, I start with the algorithm. So I always divide the highest exponent in the dividend by the highest exponent in the divisor. So 3x squared is divided by x, and the answer is 3x. So step number 1, I repeat, I divide the highest by the highest, I mean the highest exponent by the highest exponent, and write the answer here. Second step, I multiply the answer by the divisor. In other words, I distribute it over the divisor. So 3x times x becomes 3x squared, and 3x times -1 is -3x. Third step, I change the signs of the answer that I got. So the first term has a sign plus, so I make it minus. The second term has a sign minus, I change it into plus. Well, why do I do that? Because simply you need to subtract this minus that. And when I say subtract, this means I have to enter the minus over this expression, which means I have to change the signs. So again, I repeat, step number 1, I divide the highest by the highest. Step number 2, I multiply. And step number 3, I change the signs of the terms that I get. Next, I add. So 3x squared minus 3x squared cancel out, and I must end up with the first term here and the first term here canceled out. Otherwise, I have a mistake. Then I add like terms, if any, so I have -2x plus 3x. This is 1x. What is next? I move the next term down, which is +6. Now we repeat the same process. So highest exponent divided by highest exponent, which means x divided by x. X divided by x is equal to 1. So I put +1 here. Then, what is the next step? What do you think? I again distribute the 1 over what? Over the dividend, which means I multiply. So 1 times x is x, and 1 times -1 is -1. I then change the sign, so plus becomes minus, and minus becomes a plus. And then I add. Now x and x cancel out. 6 and 1 is 7. Now let us apply the division algorithm here. So we said that the dividend is equal to the divisor times the quotient plus the remainder. And in our expression, this is the quotient, and as we said, this is the remainder. Well, I'm going to use small r here. Doesn't matter whether you use small r or capital R. Capital R. So the answer will be the dividend, which is 3x squared minus 2x plus 6, equals the divisor, and this is x minus 1, times the quotient, which is 3x plus 1, plus the remainder, which is 7. And if you do the calculation, if you just simplify this expression, you must end up with the dividend. Now there is another way to write or to apply the division algorithm, and this way of writing it is really very helpful, especially when we try to find the so-called oblique asymptotes. When we do functions, when we try to find the asymptotes of functions, as you will see in a later video when I start talking about calculus. So what is that? So if I have d equals to dq plus r, so what is that? Let me write again d equals to d little d times q plus r. And let's divide every single term by d. What happens here? These cancel out. So this is equivalent to saying capital D over small d is equal to q plus r over d. This is really very helpful, as I mentioned, when we try to find oblique asymptotes of functions. So let us apply it on our example. This becomes 3x squared minus 2x plus 6, that's the dividend over the divisor, which is x minus 1, is equal to the quotient, which is 3x plus 1 plus the remainder 7 over the divisor again, which is x minus 1. Now I'm going to repeat the same example. Some students follow this way of dividing. So instead of using this format, they use that format. So here, if you're using this, I have to place the dividend and the divisor, and all the terms, all the terms, yeah. If you're using this, then all the expressions are changed in places. So the dividend will be here, the divisor will be here, the quotient will be here, and finally the remainder will be here. But everything else will be the same, as I will show you now. So we have 3x squared minus 2x plus 6 divided by x minus 1. And I play the same game. So highest by highest. So 3x squared divided by x, that is a 3x. Then I multiply the 3x by the divisor, and I put the answer here. So it is 3x squared minus 3x. Then we change the signs. We add. These terms cancel out. Negative 2x plus 3x, that's a positive x. Then I move the positive 6. Repeat the same process. So x divided by x, that is 1. Then I multiply 1 by x minus 1. So that is just x minus 1. Change the signs. So that becomes minus. This becomes plus. We add up. The first terms cancel out. And the second terms, 6 plus 1, give me 7. And here you go. So this is the quotient. This is the remainder again. That's the divisor. And of course, this is the dividend. Let's do example 2. Here I have x to the power of 5. Now here there is no x to the power of 4. So to avoid any confusion, I prefer to write 0 x to the power of 4 minus 2x cubed minus 3x to the power of 2 plus 9. And x squared minus 2 is placed here. We play the same game, so x to the power of 5 over x to the power of 2. That is x to the power of 3. I multiply x to the power of 3 by x squared minus 2. So x to the power of 3 times x squared, that is x5. And x cubed times negative 2, that is a negative 2x to the power of 3, but I make sure to place it underneath the term which contains x to the power of 3. So it is placed here, negative 2x cubed. Change the signs, right? Then I change the signs and add. So x to the 5 cancels out with x to the 5, as well as negative 2x cubed and positive 2x to the power of 3. Then I move the 3x or the negative 3x squared down. And let us also move the 9 down as well. Why did I do that? Well, because when you multiply, you're going to end up with 2 terms, which means there is a possibility to add the next term with 9. So this is why I just moved both terms down. So negative 3x squared divided by x squared, that is a negative 3. And then I multiply the minus 3 by x squared, which is minus 3x squared. Then minus 3 times negative 2, that's a positive 6. And this is what I meant by having 2 terms. And since 6 is added to 9, then I must move the 9 down when as well as negative 3x squared in this simultaneously. Then we change the signs, so this becomes plus and this becomes minus. Then I add, those cancel out, and 9 minus 6 is 3. Again, that is the remainder, and that is the quotient. In example number 3, again, that's more practice. I will choose to do it this way. So I have x to the power of 4. There is no x cubed, So I make sure to add 0x cubed minus 6x to the power of 2 plus 5x plus 4. And here I put x minus 2. So x to the power of 4 divided by x, that is x to the power of 3. I multiply. So x to the power of 3 times x, that is x to the power of 4. And negative 2x cubed. I change the sign, so this becomes minus, this becomes plus. We cancel these. So we have 2x cubed. So I move the negative 6x squared down, so it becomes here. Then 2x to the power of 3 divided by x, that is plus 2x squared. I distribute. This becomes 2x cubed minus 4x squared. I change the signs. This is a minus, that is a plus. Cancel out. That is a negative 2x squared. Then I move the 5x down. Then negative 2x squared divided by x. That's a negative 2x. Negative 2x, multiply it. This becomes multiplied by x minus 2. This becomes negative 2x squared plus 4x. I change the signs. This is a plus. That is a minus. Cancel out. That is 1x. And finally, we move the 4 down. So x divided by x, that is 1. And then I multiply, so this becomes x minus 2. Change the signs, minus and plus. And finally, we get 6, which is our remainder. And that's the third example. This is a shorter method. However, it only works if there is a certain condition that is satisfied. What is this condition? The divisor must first of all be linear. What do I mean by linear? I mean the highest exponent is 1. So the degree of the divisor must be 1. That is a linear factor. And the coefficient of the highest exponent, which we call the leading coefficient, has to be 1. Otherwise, it doesn't work. So I have to make sure that the divisor is linear and the coefficient of x is equal to 1. If these conditions are satisfied, so let me show you how to place the terms here. I do something like that. Here, I first of all only place the coefficients of the dividend. So we have 3, we have negative 2, and we have 6. So I do not write the x's at all. And I write the 0 of the divisor. What do I mean by the 0 of the divisor? I mean if I have x minus 1 is equal to 0, this gives us x is equal to 1. So if you solve x minus 1 is equal to 0, it gives you 1. This is called the 0 of the expression or the root of the expression. So the answer that you get, you put it here. Okay, let's start with the algorithm. I always move the first term down. So whatever the term is, I always move it down. Then the number that I get, I multiply by the 1 and then add it to the next term like this. So multiply, then add. Always like that. So 3 times 1 is 3, plus minus 2, that is a 1. The answer that I got, I write it here. Okay, now we repeat the same scenario. I multiply 1 by 1, and then the answer I add it to 6. 1 times 1 is 1, plus 6 is 7. Now, what are these numbers that I have just obtained? The final number is always going to be the remainder, always. And the other numbers are just the coefficients of the quotient. This stands for 3x, and this stands for 1. So the answer is 3x plus 1. Therefore, 3x squared minus 2x plus 6 over x minus 1 is equal to the quotient that I just got, which is 3x plus 1, plus the remainder, that is 7 over x minus 1. As I mentioned, it's way faster than long division, but it only works if the bottom term or the divisor is linear with a leading coefficient equal to 1. Let us do another example. I place the coefficients of this term. So we have 1, x to the power 4. I'm missing x to the power 3. I must put a 0 here. So please do not forget to do that. Otherwise, everything will be wrong. Then negative 6x squared plus 5x plus 4. If I solve x minus 2 equal to 0, I get 2 as the answer. Let's repeat the same process. So 1, you move it down. Always the first term, you move it down. Then I multiply by 2, and the answer I add to 0. So 1 times 2 is 2, plus 0, it's 2. Next, 2 times 2, and the answer plus minus 6 is a minus 2. Minus 2 times 2 is negative 4, plus 5. Negative 4 plus 5 is 1. Finally, 1 times 2 is 2, plus 4, that is 6, and the 6 is the remainder. So let's see what the quotient is. This stands for 1. This stands for negative 2x. This stands for 2x squared. And this stands for 1x to the power 3. So therefore, the quotient becomes x cubed plus 2x squared minus 2x plus 1, and the remainder is equal to 6. And this is simply what is meant by the synthetic division. A very common question in this topic is the following, something like that. Check if q of x equals to some polynomial is a factor of another polynomial p of x. Whenever you have something like that, it's meant to check whether the remainder is 0 or not. If the remainder is 0, then yes, q of x is a factor of p of x, otherwise is not. And as you can see here in this example, the remainder is 0, and I simply write it as p of x equals to the quotient, which happens to be 3x squared minus 2x plus 6, multiplied by the divisor, which is x minus 1, and there is no remainder because it's just 0. That's all about division. See you soon, and thank you.